Hi, this is Vishnu, and this is my final version of the elevator project. So this version of the elevator project is slightly different than previous years in which there was no ground state button. And basically the purpose of the ground state button is that when the elevator is in idle state, meaning that the button pressed is the same as the current level of the elevator, um, when the ground button is pressed, the elevator will go to ground regardless of what other buttons are pressed, and it will continue to go down until that ground level is reached. Um, so right now I'll just demonstrate a few different situations to show that this works. Keep in mind that here this top LED, the one above, is for up, and the one below is for ground. Currently it's in idle state, which means that the elevator is not moving. So right now I've hardwired my current level of the elevator to be at level 4, and these LEDs right here resemble the level of the elevator button that's pressed. These are binary values, so this is representing 1, 2, 4, and 8, and you add these numbers together to get the final value. So right now I'm at level 4. This is also my clock, which I made earlier on the semester. So essentially, let me start by pressing level 0. So we see that there is a level of 0 indicated here, and only the down state is shown. So we can go through them. Level 1 should still be down. Level 2 should still be down. Level 3 should still be down. Level 4 should still... So level 4 is when we reach idle state, which I was in before. Now if we go to a level where we're higher than the current floor, only up will be on. We can go through all of these, but it will be the same. You can see the LEDs up top moving to represent level, and it'll go all the way to 15, since it's a 4-bit number. So let's go back to idle state to show that this works. Also, let me show you that when I go straight from going up to going down, this will work. So we're at level 15 right now. Let's press level 2, and it'll go straight to down. Let's go to level, I don't know what level this is, but it'll be above 4. It'll go straight to up. So let's find idle state right there. So now if I'm in idle state and I press this ground state button, we should go directly to ground, which means we'll go down until the current floor level equals 0. So let's press that button right now. And sure enough, we're going down. So now the only way to get out of this state is for the current floor to be 0. So I'll have to change the hardwiring. But let me show you, regardless of what I press. I'm pressing buttons. Nothing will happen. I'll have to change the hardwired value to all zeros. So I'm going to move this wire, make that a 0. And now we're going up. And the reason for this is because these registers, which I'll go into later, they're currently holding the value of the last button that was pressed. And I guess the last button that was pressed was 14, level 14. So that is why we're in upstate. And if we go to level 14, we'll be back at, maybe it's not, what am I doing, sorry. But if we go to level 0, we'll be in idle state again, because that's the current level. So now I'll go into how this works. So I'll leave it on for now. So basically we're feeding all of these buttons, which are active high. We're feeding those buttons into 2 priority encoders. And when I cascade these priority encoders using an AND gate, there's one specific AND gate that will feed into a multiplexer. Basically what these priority encoders do is that they create a 4-bit value that will be used for comparator, which is what we're comparing to the current floor of the elevator. if we're actually using the elevator, this value will be the value that is picked up by sensors in the elevator to tell you the current level. So basically, the way we got our 4-bit numbers accurately was there were certain AND gates that were shown on the PowerPoint slides. That is what we used. And one of the big parts of this step is the multiplexer. We're feeding the multiplexer a specific enabler value. This pin is A bar B, and this is the multiplexer right here. You can see this goes to our AND gate right here. And basically what this does is it tells the multiplexer which value should be outputted. So there's two different values. Obviously there's the values from the priority encoder in the multiplexer, which are all listed as A values, and there are values that are directly from the register output, which are listed as the B values. So when there's no buttons pressed, that means we want the register to hold the last input. So the multiplexer will output the register values and input them back into the register. However, if there is a button being pressed, the register value will essentially quote-unquote refresh. So basically from the register, we want to bar these values since these push buttons are active high, and we want to compare them to the sensor values. That chip right there is the comparator. And this comparator outputs one of 3 different outputs. One is greater than 0, or one is greater than the sensor values, less than the sensor values, or equal to the sensor values. The rest, all of this is pretty much just combinational logic, which I won't go into too much. But finally, we have a little bit more combinational logic. Basically, the main part of this is that this is the register. This holds 2 register values that will eventually be used in some more combinational logic to finally get our up and down values. So some things I ran into, I did not have access to certain chips such as XOR or NOR chips. So all of this right here, all of these red wires are where I had to essentially cascade 2 AND gates and OR their outputs together to get the equivalent of an XOR gate. So that was one thing. Also, I didn't have access to a NOR gate, which meant I had to do a little bit more logic at the end after I got my register values for my up and down. And yeah, that's about it. Also, one of the other things I ran into was making sure I stayed organized. And I made good use of the VDD, the beeper function. Also, I had to switch out my inverter pin. For some reason, it wasn't working initially, but now it does. So yeah, thank you guys.